Hello everyone, welcome to this theory recording on the superposition principle. So the superposition principle states that the voltage or current over an element is equivalent to the sum of the individual voltages or currents contributed to by the independent sources of the circuit. So what this means is that if you have a circuit that has multiple independent sources, then you are able to add the individual influence of those independent sources in order to get the impact of the whole circuit towards a certain value that you're looking for, be it the current or the voltage. What would the procedure for this be? The first step would be to set all your independent sources to 0 except one. So only consider one source at a time. Deactivate all your other sources. When we say set them equals to 0, you'll remember that setting a voltage source or deactivating a voltage source means you replace it with a short circuit which has a voltage value of 0. Deactivating a current source implies you replace it with an open circuit which has a current value of 0 amps. The second step would then be to solve for the necessary currents and voltages using only that one independent source that's activated. Step 3, repeat step 2 for each of the sources that are connected to the circuit. And then finally, add all the individual voltage or current results together to obtain one final answer. So if we look at this example, you've got two independent voltage sources, and if they had requested, or if they request for you to determine the value of I1 and or I2, you then need to consider the individual contribution of those sources. So you know that there will be an I1 and an I2 due to the source on the right hand side, and there will be an I1 and an I2 due to the source on the left hand side. Once you calculate these values of I1 and I2, you can then add them together. So the total current I1 will be I1 due to the first source plus I1 due to the second source, and the value of I2 will be I2 due to the first source plus I2 due to the second source. Let's take a look at an example. The example that's indicated here requests us to determine the voltage V0, that's the voltage over the 6K resistor, and we can see that we have two independent sources, the 12 volt source and the 6 milliamp source. So we will then need to consider one source at a time. So find V0 using superposition. The first step will then be to determine V0 when considering only the current source. So the voltage source will become a short circuit. That's what you see over there. What happens to the 6K and the 6K? Because you have a short circuit, the current that would have come through into this part of the circuit has the option of a short circuit or 6K and 6K 12K resistor to flow through. So that current will always bypass the branch of these two resistors, and thereby we have the circuit that only just has a short circuit there. So the short circuit has bypassed these two resistors. Now we need to calculate the value of VO. For us to calculate VO, we need to calculate the current flowing through there, and then we can multiply it by the resistance. For us to calculate that current, we can use current division. So I1 will give you 6 milliamps times 6K plus 6K, so the opposite resistor branch, over the sum of all the resistors, times the source, which is 6 milliamp. We find a value of 4 milliamps. Then we calculate the value of VO due to the first source. You find that VO will then be given by 6K multiplied by minus 4 milliamps. Where does the minus come from? You'll notice that current is not flowing in a voltage drop direction, which is the natural direction of current flow. It's flowing, or it's indicated in a voltage rise direction, which then should tell us that the current value should be negative. Right, and that will give you a value of 24 volts for the VO. Then we determine VO due to the voltage source, the 12 volt voltage source. So the current source is replaced with an open circuit, and now we must get the voltage V0. How will we get this voltage? We could use a KVL in that loop, and by doing KVL in that loop, you could also look at voltage division, because this 12 volts is going to be dropped over the 6K and the 6K, as well as the 6K, 6K, and 6K. And that's what has been conducted in this area here, where we've used voltage division to determine the voltage V0. And it is found that V0 is then equal to 4 volts. Finally, we will then add the values of V0 due to the first source and the second source. So we will have a value of minus 24 volts plus 4 volts to give you a final value of minus 20 volts. Thank you for watching the video and enjoy the course.